Hey everyone, and welcome back to the channel. Today's video is all about liner wear, something that affects us all, whether we are talking about car brakes, industrial machinery, or even something as simple as the lining in your favorite jacket. We'll be looking at the different types of liner wear, the common causes, and most importantly, how to identify and prevent it before it becomes a major problem. I'll be sharing some practical tips and tricks based on my own experience, so stick around for the next 10 minutes or so, you won't regret it. Hey everyone, let's dive into the world of engine liners and explore the main reasons why they wear out. We'll be focusing on main and connecting rod liners specifically. First off, let's talk about what these liners actually are. They are essentially cylindrical sleeves, usually made of a durable material like cast iron or steel, that are installed inside the engine block. Their purpose is to provide a smooth, lubricated surface for the crankshaft and connecting rod journals to rotate on. This minimizes friction, reduces wear, and helps maintain the engine's overall efficiency. Think of them as the protective armor for your engine's vital moving parts. Without them, you'd have metal-on-metal contact, leading to catastrophic failure pretty quickly. Now, let's get into the nitty-gritty, the reasons why these liners wear out. One of the biggest culprits is the ingress of foreign matter. This could be anything from dust and dirt particles to larger debris like metal shavings. These contaminants act like microscopic sandpaper, gradually grinding away at the liner's surface. The smaller the particles, the more insidious the damage, as they can embed themselves in the lubricating oil film and cause significant abrasion over time. Regular oil changes and proper filtration are crucial to minimizing this type of wear. Another significant cause of liner wear is dirt erosion. This is a bit different from foreign matter ingress. Dirt erosion is more about the abrasive action of dirt particles suspended in the lubricating oil. Imagine a tiny sandstorm happening inside your engine. The constant bombardment of these particles, even at relatively low speeds, can gradually erode the liner's surface, leading to scoring and pitting. Again, maintaining clean oil is paramount. Corrosion abrasion is another factor we need to consider. This occurs when corrosive substances, often present in the oil or even from condensation within the engine, react with the liner material. This chemical reaction weakens the liner's structure, making it more susceptible to wear. Using the correct type of oil and ensuring proper engine ventilation can help mitigate corrosion. Metal fatigue is a less obvious but equally important cause of liner wear. Over time, the constant cyclical loading and unloading of the crankshaft and connecting rods can cause microscopic cracks to develop in the liner material. These cracks propagate over time, eventually leading to significant weakening and failure. This is often exacerbated by factors like excessive engine vibration or overloading. Finally, we have wear due to tin penetration. This is a more specialized issue, often related to the composition of the bearing material. If the tin content in the bearing material is too high, it can penetrate the liner material, leading to softening and increased wear. This is less common but highlights the importance of using correctly specified bearing materials and ensuring proper lubrication. The interaction between the liner material and the bearing material is critical for long-term engine health. Getting this wrong can lead to premature liner wear and engine failure. Hey everyone, let's dive into the world of liner wear. It's a crucial topic for anyone working with engines, and understanding the causes is key to preventing costly repairs. First up, we've got surface corrosion. This sneaky culprit can significantly impact liner lifespan. Think about it, even microscopic amounts of moisture or contaminants in the oil can lead to electrochemical reactions, slowly eating away at the liner's surface. This is especially true if the engine isn't properly protected during storage or if there's a problem with the engine sealing system allowing moisture ingress. We are talking about pitting, roughness, and ultimately, reduced performance and increased friction. The severity depends on factors like the environment, the type of metal used in the liner, and the presence of corrosive agents in the oil. Proper oil selection and regular maintenance are absolutely vital here. Next, let's talk about insufficient lubrication. This is a big one, and probably the most common cause of liner wear. Without enough oil, or with oil that's degraded or contaminated, the metal-to-metal contact between the piston and the liner increases dramatically. This leads to increased friction, heat, and ultimately, wear. We are talking about scoring, galling, and even seizing all catastrophic failures. The pressure exerted on the liner during operation is immense, and without a proper lubricating film, that pressure translates directly into destructive wear. Think about the consequences: engine failure, costly repairs, and potential downtime. Regular oil changes, using the correct viscosity oil for your engine, and ensuring your oil pump is functioning correctly are all critical for preventing this type of wear. Now, let's shift our focus to the crankshaft journals. Improper machining of these journals can have a ripple effect, leading to uneven wear on the liners. If the journals aren't perfectly round and smooth, the connecting rods won't be able to move freely, causing uneven pressure distribution on the liners. This uneven pressure leads to accelerated wear in certain areas, while other areas might remain relatively untouched. This is a manufacturing defect that can be difficult to detect, but it's something to keep in mind if you're experiencing premature liner wear. Precision machining is essential to ensure the longevity of the engine components. Surface scratches are another common cause of liner wear. These can be caused by various things, from debris in the oil to improper installation of the piston rings. Even tiny scratches can act as stress risers, concentrating pressure and accelerating wear. Over time, these small scratches can grow larger and deeper, leading to significant damage. Regular oil filtration and careful handling during assembly are crucial to minimize the risk of surface scratches. Think of it like a tiny cut on your skin. It's small at first, but it can become infected and much worse if not properly cared for. Then there's excessive erosion due to cavitation. Cavitation is the formation and collapse of vapor bubbles in a liquid, usually due to changes in pressure. In an engine, this can occur in the lubricating oil, leading to tiny, high-velocity impacts on the liner surface. These impacts can cause pitting and erosion, gradually wearing away the liner material. This type of wear is often difficult to detect in its early stages, but it can lead to significant damage over time. Maintaining proper oil pressure and using the correct type of oil are key to preventing cavitation. Misalignment is another significant contributor to liner wear. If the engine components aren't perfectly aligned, the piston will move unevenly within the cylinder, leading to increased friction and wear on one side of the liner. This uneven wear can cause the liner to become oval-shaped, leading to further problems. Precise alignment during assembly is crucial to prevent this type of wear. It's a subtle issue, but the consequences can be quite severe. Finally, let's talk about prevention. Regular maintenance is paramount. This includes regular oil changes, using the correct type and viscosity of oil, ensuring proper oil filtration, and carefully inspecting the engine components for any signs of wear or damage. Proper engine installation and alignment are also crucial. And remember, prevention is always cheaper and easier than repair. By addressing these potential problems proactively, you can significantly extend the lifespan of your engine and avoid costly repairs down the line.